Hello class, we are beginning chapter 11, sequences and series. We'll be working on arithmetic sequences and series, geometric sequences and series, and toward the end of the chapter we'll be using rectangles to approximate area under the curve. To begin with, I'd like you to do the check skills you'll need. Let's do 4 of those problems. I'd like you to do questions 1, 2, 5, and 6. So please do those 4 problems, 1, 2, 5, and 6. Pause your device and then pick it up again once you have completed those problems. So hopefully you've completed these problems. Number 1, your next 2 terms should be 13 and 15, adding 2 to each one to the previous term. Number 2, you are decreasing by 2, so you're subtracting by 2 to each term. So your next 2 terms should be negative 14, negative 16. Number 5, your next 2 terms, when you look at this problem, would be 8 and 4 because you're dividing each term by 2 to get to the next term. And number 6, you see that you are adding 3 to each successive term. So your next 2 terms are 20 and 23. We're going to skip the investigation, generating a pattern, and move right down to our sequences and term, looking for those definitions. A sequence is simply an ordered list of numbers. An ordered list of numbers. For example, we could say something like this: 5, 10, 15, 20, and so forth. That's an ordered list of numbers. A term is simply a particular number in a sequence. So from the above example, we would say 15 is a term. Now I got example 1. We're going to start with a square at least 1 unit long, or of 1 unit long, and we're going to add onto that square successive squares, each with 1 unit of length. So the first part, we're going to just try to create a pattern, and our first square might look, or should look, something like this. There's our square. Now we're going to add another square onto the side of it, so our next square might look something like that. And the following square, if we're going to add onto that, would look something like that. And we'll go one more. And you can see, hopefully, that I'm adding 3 segments to each square. So if we write this out, I'm going to have 4 sides. If I count the number of segments, I'm going to have 7 here. If I count the number of segments all around my squares, I'm going to have 10. And then I'll have 13, and so forth. So B says, write the number of 1 unit segments in each figure above. So we've done that. We've got 4, 7, 10, and 13. The C part says, predict the next term of the sequence. Well, without having to draw the picture now, we can certainly see that we are adding 3 to each term. So our next term would certainly be 16, and the number after that would be 19, 22, and so forth, because we are adding 3 to each previous term. Okay, I think that's fairly clear and fairly obvious. So take a moment and do the check understanding. Just find the next 3 terms for check understanding A and B. So I hope you have completed this, you've paused and completed this problem for check understanding. The next 3 terms for this check understanding 1A would simply be by adding 7 to each one. I've got 55, seven to that would be 62, and 7 to that would be 69. For B, it looks like we are dividing by 3 each term. So we got 243, 81. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 would be 1/3. So I hope you have gotten those correct. Looking at example 2, we have a problem that says suppose you drop a ball from a height of 100 centimeters. It bounces back to 80% of its previous height. How high will it bounce after the 5th bounce? So we have a situation that looks something like this. We're going to call that, say that's 100 centimeters, and we're going to drop a ball and it goes down and then it bounces back up to 80% of its original height. We'll say that 80% is right there. Then it's going to go down again, bounces up to 80% of its original height there, and it's going to go down again, bounces up to its, we'll say that's 80% of its original height, and it keeps on going, and we're wondering how high it's going to be after the 5th bounce. So far we've got, there's our first bounce, second bounce, third bounce, fourth bounce. We got to go one more time, and we'll start here, and we're going to go down and then up 80%, and we are wondering how high the ball goes at that point. So working this problem out, if I'm starting at 100 and I'm going to go up 80% of the way, I'm simply going to multiply 100 by 0.8 or 0.80, and my height here is then 80. I'm going to have to take that 80 times 0.8 because I want 80% of that height, and that would end up to be the value 64. I'm going to have to take that 64 times 0.8, and I'm going to end up now with 51.2. I'll take that 51.2 times 0.8, and I'll end up with 40.96. And one more time, that 40.96 times 0.8, and I'll end up with 32.786. And that's the height of my ball after 5 bounces. And we can do this with a nice picture like this, or we can maybe do it a little bit more efficiently, and we'll show that on the side here. I would start at 100, and I'm going to multiply that by 0.8, and I get 80, of course. That's my height after my first bounce. Then I'm going to take that 80 and I'm going to multiply that by 0.8, and I get 64. I'll take that 64 and multiply it by 0.8, and I get 51.2. I'll take that 51.2 times 0.8, and I end up with 40.96, and finally 40.96 times 0.8, and I end up with 32.786, and that's the height after the 5th bounce. That concludes Chapter 11, Section 1, an introduction to sequences. You may now begin working on your assignment for this section.